Hello guys, welcome to Thrin Check YouTube channel. In this video we will be talking about software development. All you need to know about software development as a beginner. Software development is the process of designing, coding, testing, and maintaining software applications and systems. It plays a crucial role in creating software that powers a wide range of devices and services. Software development involves writing code to instruct a computer on how to perform specific tasks or functions, and it encompasses various stages, such as planning, coding, testing, and debugging. Now let's move on to the key concepts of software development. Number 1. Programming languages. Developers use languages like Java, Python, C++, and JavaScript to write code. A programming language is a formal system designed to express instructions that can be executed by a computer. It provides a set of rules and syntax for creating software and allows developers to write code that instructs a computer to perform specific tasks. Programming languages enable humans to communicate with computers by providing a way to convey algorithms and logic in a format that the computer can understand and execute. Number 2. Development environments. Integrated development environments (IDEs) provide tools for coding, debugging, and testing. IDEs are software applications that provide comprehensive facilities to programmers for software development. These environments typically include a code editor, debugger, build automation tools, and often a graphical user interface GUI builder. The main purpose of an IDE is to streamline and simplify the development process by consolidating various aspects of programming into a single integrated tool. Number 3. Version control. Version control systems like Git help manage changes to code. Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. It allows multiple contributors to work collaboratively on a project by keeping track of changes made to the source code, documents, or any other files. Popular version control systems include Git, Mercurial, and Subversion. Git, in particular, has gained widespread adoption due to its distributed nature, speed, and flexibility. Many platforms, such as GitHub, GitLab, and Bitbucket, provide hosting services for projects using version control, making it easier for developers to collaborate, share code, and manage their projects. Number 4. Development life cycle. The software development life cycle, SDLC, includes phases like planning, design, implementation, testing, deployment, and maintenance. The software development life cycle is a systematic process for planning, creating, testing, deploying, and maintaining information systems. It provides a framework for software development projects, ensuring that they are well organized and follow a structured approach. The software development life cycle aims to produce high-quality software that meets or exceeds customer expectations, while staying within time and budget constraints. Now let's move on to types of software development. Number 1. Web development. Web development refers to the process of building and maintaining websites or web applications, creating websites and web applications using technologies like HTML, CSS, and JavaScript. It involves a combination of programming, design, and other skills to create a functional and visually appealing online presence. Number 2. Mobile app development. Building applications for smartphones and tablets, often for Android and iOS. Mobile app development is the process of creating software applications designed to run on mobile devices, such as smartphones and tablets. It involves a combination of programming, design, testing, and deployment to produce applications tailored for specific platforms like iOS or Android. Number 3. Desktop application development. Desktop application development refers to the process of creating software applications that are designed to run on a desktop or laptop computer. Developing software for desktop operating systems like Windows, Mac OS, and Linux. These applications are installed locally on a user's device and typically interact with the operating system and other software installed on the computer, unlike web applications that run in a web browser. Desktop applications have a standalone presence on the user's machine. Number 4. Embedded systems development. Embedded systems development involves designing, programming, and testing embedded systems, which are specialized computing systems that perform dedicated functions within larger systems or products. It also involves designing software for embedded devices, such as IoT devices and consumer electronics. These systems are embedded into devices or machinery to control specific functions, often in real time and with specific constraints on size, power consumption, and processing capabilities. Number 5. Game development. Game development is the process of creating video games for various platforms involving the design, programming, testing, and deployment of interactive and entertaining software. The game development process often follows iterative cycles, with continuous testing and refinement. Game developers may use game engine software frameworks that streamline the development process and provide tools for graphics, physics, sound, and more. Popular game engines include Unity and Unreal Engine, which are widely used for developing a variety of games across different platforms. Game development is a dynamic field that combines creativity, technology, and entertainment to produce interactive experiences enjoyed by players around the world. Number 6. Backend development. Backend development refers to the server side of web development, where the logic, database interactions, and other server-related tasks are handled, focusing on server-side logic and databases to power web and mobile applications. It's responsible for processing data, managing databases, and performing other functions that enable the front-end client side of a web application to operate seamlessly. Frameworks like Express.js for Node.js, Django, Ruby on Rails, and Flask provide structures and tools to streamline back-end development. Number 8. Full-stack development. Full-stack development refers to the practice of working with both the front-end client side and back-end server side of a web application. A full-stack developer is someone who has expertise in a range of technologies and can contribute to various aspects of the software development process. Full-stack developers have a comprehensive understanding of the entire development stack, allowing them to work on both front-end and back-end tasks. Now let's move on to development methodologies. Number 1. Agile. Agile is an iterative and incremental approach to software development and project management that emphasizes flexibility, collaboration, and customer satisfaction. Agile methodology is a response to traditional project management methodologies such as the waterfall model, which often involve lengthy planning phases and rigid structures. Common Agile frameworks and methodologies include Scrum, Kanban, and Extreme Programming XP. Scrum, in particular, is widely used and defines specific roles such as Scrum Master and Product Owner ceremonies, like sprint planning and daily stand-ups, and artifacts such as the product backlog and sprint backlog. Number 2. Waterfall. The waterfall model is a traditional and linear project management methodology for software development. It follows a sequential approach, where progress is seen as flowing steadily through a series of phases, much like a waterfall. One of the main criticisms of the waterfall model is its inflexibility in handling changes. Once a phase is completed, it is challenging to revisit earlier stages without disrupting the entire process. This can be a limitation in dynamic projects, where requirements are likely to evolve. Number 3. DevOps. DevOps is a set of practices and cultural philosophies that aim to improve collaboration and communication between software development dev and IT operations teams. The primary goal of DevOps is to enable organizations to deliver high-quality software products more rapidly, reliably, and efficiently, It involves the integration of people, processes, and tools across the software development life cycle. DevOps practices are often facilitated by tools and technologies that support automation, collaboration, and monitoring. Common DevOps tools include Jenkins, Docker, Kubernetes, Ansible, and others. Implementing DevOps principles can lead to faster delivery of features, improved collaboration, increased reliability, and better overall alignment between development and operations teams. The adoption of DevOps is a strategic choice for organizations looking to stay competitive in a fast-paced and evolving technological landscape. Number 4. Scrum. Scrum is an agile framework that uses short development cycles, sprints, for managing and organizing work, particularly in software development. It provides a flexible and iterative approach to project management and product development, emphasizing collaboration, adaptability, and delivering incremental value. Scrum is widely used in various industries beyond software development. Scrum is known for its simplicity and adaptability, making it suitable for projects where requirements may change and a flexible approach is needed. It promotes transparency, inspection, and adaptation throughout the development process. Many organizations have adopted Scrum to improve collaboration, increase productivity, and deliver valuable products more efficiently. Let's move on to software development tools. Number 1. Text editors and IDEs. Text editors and integrated development environments (IDEs) are software tools used by developers to write, edit, and manage code. While both serve the purpose of editing code, choosing between a text editor and an IDE often depends on personal preference, the development workflow, and the specific requirements of the project. Some developers prefer the lightweight nature and speed of text editors for quick edits or when working on smaller projects, while others prefer the comprehensive features and integrated workflows provided by IDEs, especially for large-scale development projects. Popular text editors and IDEs are continually evolving, with new features and improvements added to enhance the coding experience. The choice between them is subjective and can vary based on individual preferences and project requirements. Number 2. Version control systems. Version control systems (VCS) are tools that help manage changes to a project's source code, documents, or any set of files over time. They enable multiple contributors to work on a project simultaneously, track changes, and maintain a historical record of revisions. Version control is essential for collaborative software development, providing mechanisms to coordinate and integrate changes made by different team members. Git has become one of the most widely used version control systems and is especially popular in open source and collaborative development. Platforms like GitHub, GitLab, and Bitbucket provide hosting services for Git repositories, facilitating collaborative development with features like pull requests and code reviews. Number 3. Testing frameworks. Testing framework, in the context of software development, is a set of guidelines, conventions, and tools that provide a structured and systematic way to perform software testing. Testing frameworks help organize and automate the testing process, making it more efficient, scalable, and maintainable. They typically include libraries, tools, and practices that simplify the creation, execution, and analysis of tests. The choice of a testing framework depends on the programming language, the type of testing, e.g. unit testing, integration testing, etc., and the specific needs of the project. Number 4. Project management tools. Project management tools are software applications or platforms designed to help teams and individuals plan, organize, and track the progress of projects. These tools provide a centralized platform for collaboration, communication, and the management of tasks, resources, and timelines. They aim to streamline project workflows, improve efficiency, and facilitate successful project delivery. The choice of a project management tool depends on the specific needs of the project, team preferences, and the scale and complexity of the work. These tools play a critical role in improving project transparency, communication, and overall efficiency. Number 5. Database management systems. Database management system is software that provides an interface for interacting with databases and efficiently managing the storage, retrieval, and organization of data. It serves as an intermediary between the database and the users or application programs, ensuring data integrity, security, and ease of access. Database management systems are foundational components in modern software development, providing efficient and organized ways to store and retrieve data. The choice of a specific database management system depends on factors such as the nature of the data, the requirements of the application, and the preferences of the development team. Now let's move on to skills required for software development. Number 1. Programming skills. Programming skills refer to a person's ability to write, understand, and manipulate computer code to develop software, applications, websites, or other digital solutions. These skills are fundamental for anyone working in the field of software development or related technology roles. Programming involves translating logical and algorithmic concepts into a language that computers can understand and execute. Programming skills are valuable across various domains, including web development, mobile app development, data science, artificial intelligence, and more. Whether you're a software developer, data scientist, or engineer, having strong programming skills is a foundational requirement for success in the tech industry. Number 2. Problem solving. Problem solving is a cognitive process that involves finding solutions to challenges or overcoming obstacles. It's a skill that individuals use to analyze, evaluate, and resolve issues, whether they are logical, mathematical, interpersonal, or technical in nature. Effective problem solving often requires a combination of analytical thinking, creativity, and critical reasoning. Effective problem solving often involves a combination of logical thinking, creativity, persistence, and collaboration. It is a skill that can be developed and honed through practice, experience, and a willingness to learn from both successes and failures. Number 3. Communication. Communication is the process of exchanging information, ideas, thoughts, or feelings between individuals or groups. It is a fundamental aspect of human interaction and plays a crucial role in conveying meaning, building relationships, and facilitating understanding. Communication can occur through various channels, including verbal, non-verbal, written, and visual means. Effective communication is a critical skill in personal and professional settings. It fosters collaboration, understanding, and the building of meaningful relationship. Miscommunication or ineffective communication can lead to confusion, conflict, and misunderstandings. Developing strong communication skills is essential for success in various aspects of life. Number 4. Adaptability. Being adaptable refers to the ability to adjust, change, or thrive in different situations, environments, or circumstances. An adaptable person can respond effectively to new challenges, unexpected changes, and diverse conditions. This trait involves a willingness to learn, openness to change, and the ability to adjust one's behavior or strategies based on evolving circumstances. Adaptability is a valuable quality in both personal and professional contexts in the workplace. Adaptable individuals are often better equipped to handle the dynamic and ever-changing nature of modern business environments. They can contribute to innovation, problem-solving, and team effectiveness in personal life. Adaptability helps individuals navigate life's challenges, changes, and uncertainties with resilience and a positive mindset. Number 5. Debugging. Debugging is the process of identifying, analyzing, and fixing errors or bugs in a software application when a program doesn't behave as expected or produces unexpected results. Developers use debugging techniques to locate and rectify issues. Debugging is an integral part of the software development life cycle and is crucial for creating reliable and error-free software. Debugging is often an iterative and systematic process. Developers may need to revisit and refine their approach as they identify and fix issues. The goal is to eliminate errors and create software that performs as intended. Debugging is not only about fixing problems, but also about understanding the root causes and learning from the debugging process to improve future code quality. Now let's move on to software development trends. Number 1. Microservices architecture. Microservices architecture is an approach to software development where a large application is built as a collection of small, independent, and loosely coupled services. Each service, known as a microservice, represents a specific business capability and runs as an independent process. These microservices communicate with each other through well-defined APIs, application programming interfaces, and work together to deliver the overall functionality of the application. Despite its advantages, microservices architecture also introduces challenges, such as managing communication between services, ensuring data consistency across services, and dealing with the increased complexity of distributed systems. Popular tools and technologies associated with microservices architecture include containerization, e.g., Docker, container orchestration, e.g., Kubernetes, API gateways, and service mesh for managing communication between microservices. Microservices architecture is commonly adopted by organizations aiming for agility, scalability, and faster time to market in their software development processes. Number 2. Serverless computing. Serverless computing, often referred to as function as a service, FaaS, is a cloud computing model where developers can build and run applications without managing the underlying infrastructure. In a serverless architecture, developers focus on writing code functions that respond to events and are executed in stateless containers. The cloud provider automatically handles the provisioning, scaling, and management of the infrastructure required to run those functions. Popular serverless platforms include AWS Lambda, Azure Functions, Google Cloud Functions, and others. Each platform provides its own set of features, integrations, and capabilities. Serverless computing is well suited for certain types of workloads, such as event-driven applications, microservices, and scenarios where rapid scalability and cost efficiency are crucial. However, it may not be the best fit for all types of applications, especially those with long-running processes or specific infrastructure requirements. Choosing a serverless architecture depends on the specific needs and characteristics of the application being developed. Number 3. Containerization. Containerization is a lightweight, portable, and efficient method of packaging, distributing, and running software applications. Containers encapsulate an application and its dependencies into a standardized unit, making it easy to deploy and run consistently across various environments, from development to testing and production. Popular containerization platforms and tools include Docker, Podman, Containerd, and RKT, while Docker is the most well-known. Other tools and runtimes provide similar containerization capabilities. Containerization has revolutionized the way applications are developed, deployed, and managed, especially in cloud-native and DevOps environments. It facilitates a consistent and reproducible deployment process, enabling developers to build and deploy applications seamlessly across various environments. Number 4. Artificial intelligence and machine learning integration. Artificial intelligence (AI) and machine learning integration refers to the incorporation of machine learning capabilities and AI techniques into applications, systems, or processes to enhance their functionality, efficiency, and decision-making capabilities. Artificial intelligence encompasses a broader range of techniques and approaches while machine learning is a subset of artificial intelligence that focuses on training systems to learn from data. Popular frameworks and tools for artificial intelligence and machine learning integration include TensorFlow, PyTorch, Scikit-learn, and cloud-based services like Amazon SageMaker, Google Artificial Intelligence Platform, and Microsoft Azure Machine Learning. Artificial intelligence and machine learning integration is transforming industries by providing innovative solutions that leverage the power of data and computational intelligence. Its application areas are diverse, ranging from healthcare and finance to manufacturing, marketing, and beyond. Number 5. Progressive web apps. Progressive web apps are a type of web application that leverages modern web technologies to provide a more app-like experience for users. Progressive web apps are designed to be reliable, fast, and engaging, offering a seamless user experience across various devices and network conditions. They combine the best features of web and mobile applications, providing users with the convenience of web access while incorporating some of the capabilities traditionally associated with native apps. Several technologies and web standards contribute to the development of progressive web apps, including service workers for offline capabilities, web app manifest for app-like configurations, and responsive design principles for cross-device compatibility. Progressive web apps are particularly popular in scenarios where businesses want to provide a consistent and engaging user experience across various platforms, without the need for users to download and install a separate native app. They are an important part of the evolution of web development and contribute to creating a more user-centric and dynamic web. Now let's move on to career paths in software development. Number 1. Software engineer. A software engineer is a professional who applies engineering principles to the design, development, testing, and maintenance of software and systems. Software engineers play a crucial role in the software development life cycle, contributing to the creation of various types of software applications, ranging from simple mobile apps to complex enterprise systems. The role of a software engineer can vary based on its organization, project requirements, and the engineer's specialization. Successful software engineers possess a combination of technical skills, problem-solving abilities, and effective communication skills. Number 2. Front-end developer. A front-end developer is a professional who specializes in building the user interface UI and user experience UX of software applications. Front-end developers are responsible for creating the visual elements that users interact with directly in a web or mobile application. They work on the client side of the software, implementing the design and functionality that users see and interact with in their browsers or mobile devices. Popular technologies and frameworks used by front-end developers include HTML, CSS, JavaScript, and various libraries and frameworks such as React, Angular, and Vue.js. Front-end developers play a critical role in creating visually appealing, responsive, and user-friendly interfaces that enhance the overall user experience of web and mobile applications. Their work contributes significantly to the overall success of an application by ensuring that it is both functional and aesthetically pleasing. Number 3. Back-end developer. Back-end developer is a professional who specializes in building and maintaining the server-side logic, databases, and infrastructure that power software applications. Back-end developers work on the server side, handling data storage, retrieval, and the business logic that drives that application's functionality. Back-end developers often work with databases, server-side frameworks, and cloud services. They play a crucial role in ensuring that applications function correctly, handle data securely, and scale effectively to meet user demands. Common back-end technologies and frameworks include Express.js, Django, Flask, Ruby on Rails, Laravel, and Spring. The choice of technology depends on factors such as the programming language, application requirements, scalability needs, and the developer's familiarity with a particular stack. Each backend technology and framework has its strengths and use cases. Number 4. Full Stack Developer. Full Stack Developer is a professional who possesses expertise in both front-end and back-end development, covering the entire technology stack of a software application. Full-stack developers have the skills and knowledge to work on both the client-side front-end and server-side back-end of an application, allowing them to contribute to various aspects of the development process. The role of a full-stack developer is versatile, and the specific technologies and frameworks they work with may vary based on the project requirements and their expertise. Full-stack developers are valued for their ability to contribute to different parts of the development process, providing a holistic perspective on building and maintaining software applications. Number 5. DevOps Engineer. DevOps Engineer is a professional who practices DevOps, a set of practices that aims to streamline and integrate the processes of software development and IT operations. The goal of DevOps is to enhance collaboration and communication between development and operations teams, automate repetitive tasks, and improve the efficiency and reliability of the software delivery lifecycle. DevOps engineers work at the intersection of development, operations, and other IT disciplines, facilitating a smooth and efficient software delivery process. They play a key role in modern software development environments that prioritize agility, collaboration, and automation. The specific tools and technologies used by DevOps engineers can vary based on the organization's requirements and technology stack. Software development is a dynamic field that offers diverse career opportunities and requires continuous learning to keep up with technological advancements. Thanks for watching this video. Don't forget to like this video and subscribe to this YouTube channel for more videos. You can also drop any questions you have in the comments section. See you at the top.